Okay, this is a recording we're going to make having to deal with a summary of stability and capability for the anodizing process, and these are in the anodizing part 2 notes. So I'm going to go ahead and put on slideshow. So we've talked about SPC, and the data file baseline yield contains baseline capability measurement in terms of yield for the process. This is the KPI, and we're interested in yield in terms of percent defectives or loss for each lot. So we would tend to use a P chart or an individuals chart for this data. So there is an individuals chart, and you can see the process does look stable, and it seems to be running at about 18 to 19% yield. So again, we can go take a look in Jump. Let's see. Okay, so there is Jump, and I'm going to pick the right data set. So this is the yield data. This is what they've collected so far. You have lot size, number of good parts, and yield. So we could go to Analyze, okay, and we go to Quality and Process. We could go to Control Charts, and we could do a P chart. So we'll quickly review that. So the process is number of good parts, lot sequence is the sample label, and lot size is the sample size. So we click on Control, and again we get a P chart. The limits aren't entirely constant because the lot sizes change, but we reach the same conclusion that we're running about, if I can capture it there, about 19% yield, but we are stable. Okay. Likewise, we could have just calculated yield and gone ahead and done an individuals chart, and we could do this in Control Chart Builder just to be different. So yield is Y, and lot sequence is the subgroup. Since we've already calculated yield, we don't actually need lot size. And again, we come to the same basic conclusion that the process is essentially stable, running at about 18 to 19% yield. And then what about capability? So I'm going to open up a different data set, okay, for capability. And you may recall in the exploring data section, we looked at the quality characteristics, thickness, L star, A star, and B star. And from the data, we were able to set specification limits for them. Well, now we have 4 characteristics, and it turns out Jump has a nice platform for assessing capability of multiple CTQs. So we go to Analyze, okay, Quality and Process, and it's just called Process Capability. Okay. Okay. And Jump, when I hit that, it for some reason wanted to go into the background. So what you do is, where it says process, in our case, we just put in our process characteristics, okay, and we don't really need to fill in any other information here. Click OK, and it wants, let's see, no, it's not in there. I'll have to put in the specs. So for L star, it runs from 8 to 10 to 12. I'm sorry, that's thickness. I'm doing the wrong one. So this is 0.8 to to 1.12. Okay, and I didn't put that in correctly. I wanted 1.2. I'm putting in roughly what these are because I don't want to run back and look them up. I know roughly what they are for each of these. So it's 8, 10, 12. A star, I believe, is 0. Okay. 2 and 4, and I believe B star is -2 to 0 to +2. Okay. By the way, I think L star, I was just thinking about it, I think it's 0.7 to 0.9 to 1.1. I ordinarily would store these in the column headers, but in this particular data table I failed to do that. Okay, so you click OK, and you get what's called a goalpost plot. And notice that triangular region. This would be any characteristic that had a CPK of at least 1, and you can modify the size of it if you want to. I'll just leave it at around 1. But you can see we'd have to go to a very low CPK or PPK to try to capture all of these means. In other words, these are all very low CPKs. There's some options in here that are nice, such as label the points. So it's showing you all of the points, and here's what it's doing. It's centered and scaled each of the measurements by their spec limit so we can put them on one chart. If you're on target, you're at 0. If you're on the negative side, you're below target. If you're positive, you're above target. So notice B star is well off target on the low side, and the standard deviations show you the amount of variation. So you can see a lot of these, for instance, for overall, for B star, again right here, that's about 0.65. It says the standard deviation is about 65% of the spec limits. Okay, and it's off limits. And it's off target by about 1/2 the spec limits. You can also get up here, if you want, there are some summaries you can get, summary reports, overall sigma summary reports, okay, and so forth. So it can give you all kinds of values, and by the way, one of them, are the CPKs, and you can see they're all really, really bad. Okay. So basically what we learned from this, we're really incapable, and there's a lot of work to do. And given our yield is less than 19%, this is just inferring that this is a very incapable process, and there's much work to actually be done. So basically that's all I'm doing here. I'm showing you the capability, and after assessing stability with a control chart, we showed that our baseline capability is terrible. We're going to have to figure out how to run this process better, because as it stands, we're very incapable. We cannot meet specifications. Okay, and that actually ends this very short recording.